Hi everyone, today I want to review precipitation reactions with you. We'll begin by taking a macro look at what happens during precipitation, and then we're going to take a look at what happens on a particle level. Alright, so let's get started. To review, precipitation reactions occur when you have cations and anions in aqueous solution that will form an insoluble salt, or a precipitate. The general equation for a precipitation reaction closely resembles that of any double replacement reaction. In this case, we have two aqueous solutions, A, B, and CD, reacting to form two compounds, AD and CB, one of which is a solid and one of which is aqueous. In this case, I chose to make AD the solid. The complete ionic equation for this reaction is shown here, where we break down all of our aqueous solutions into ionic form, but we keep the solid written as a compound, because it does not actually break down into its ions. And then lastly, the net ionic form for this, just as a refresher, we take the two ions that are involved in forming the insoluble salt and just list those ions and the salt, because they are in fact the only species that change during this reaction. The B anion and C cation are spectator ions. Alright, so let's start with this reaction. I have two colorless solutions. In this beaker, I have a solution of silver nitrate, and in this beaker, I have a solution of potassium chloride. So let's slowly pour the silver nitrate into the potassium chloride and see what happens. All right. Okay. So our solutions turn white. What is actually white? Well, we have two possible products, so we know it's either potassium nitrate or silver chloride. We know that all nitrates are soluble, so this white solid must be silver chloride. So it looks like it's predominantly silver chloride, but really there's a fair amount of potassium nitrate in there as well. In fact, if we were to let it settle, it would look like this, where we have a solution of potassium nitrate up here, and down here, hard to see, but the silver chloride precipitate has settled to the bottom. Okay. Here on top we have the complete equation for the reaction of silver nitrate with potassium chloride to form the silver chloride precipitate. And then the second equation just shows that in net ionic form. All right, again, note that potassium and nitrate ions are spectator ions. So what does this look like on a particle level? Well, here you'll see in the diagram on the left, that represents the potassium chloride solution. So because it's an aqueous solution, we have potassium ions represented in pink and chloride ions represented in the green spheres. The second diagram represents the silver nitrate solution. So we have silver ions and nitrate ions. So the silver ions are these small grayish spheres, and then the nitrates are the larger molecules you'll see there that have a nitrogen in the middle surrounded by three oxygens. And the last diagram shows the products, and it's just like we saw in the beakers. So you have the silver chloride represented by the green and gray, that solid all along the bottom as it's settled, like we saw at the end of the demo. And then you have your spectator ions and potassium ions and nitrate ions in solution above that precipitate. Okay, so let's try another reaction. Once again, I'm starting out with two colorless solutions. In this beaker, I have a solution of lead-2 nitrate. In this beaker, I now have a solution of potassium iodide. So let's slowly pour the lead-2 nitrate into the potassium iodide and see what we get. And as you can see, just like the last reaction, we get what looks like a sort of a yellow sludge, but yellow instead of white. So what is this yellow? We know the two possible products were potassium nitrate or lead-2 iodide. And since we know that nitrates are soluble, this must be the lead-2 iodide. Okay. So this looks like it's pretty much all lead-2 iodide, but really, actually what's kind of cool is if we actually let this settle, it will eventually look like this, where we have the solution of potassium nitrate, so the potassium nitrate product is up here, and our precipitate of lead-2 iodide has settled to the bottom. Okay, so here is the complete equation for the reaction that we just saw. where we formed lead-2 iodide from lead-2 nitrate and potassium iodide solutions. So let's take a look again at what goes on a particle level. Here we have on the left our beaker representing the potassium iodide solution. So we have potassium and iodide ions, where potassium is in the gray and the iodide ions are purple. In the second beaker, that represents our other reactant, the lead-2 nitrate. So once again, we have nitrate ions, and the yellowish gold spheres represent the lead-2 ions. And our third beaker represents our products. And again, like we saw in the demo, the precipitate settles at the bottom. And so we have the lead-2 iodide at the bottom, and our spectator ions, potassium and nitrate, are in solution above that. Okay, so let's try a practice problem. In a reaction very similar to the one that we just saw, we have a solution that contains 0.150 grams of lead-2 nitrate that has been dissolved in water. That solution gets added to 125 milliliters of a 0.1 molar solution of sodium iodide. The chemical reaction that takes place is shown below, and you'll see that this is very similar. In fact, the net ionic reaction is exactly the same as the reaction that we just saw in the demo. However, what I'd like you to do is, given the information that you have here, I want you to take a look at these 5 particle diagrams. And I want you to choose the diagram that you think best represents the reaction in the practice problem. So feel free to pause the video and rewind if you want to take a look at the problem again, or you just want to have enough time to make the correct choice. Okay, so which one did you choose? If you didn't do any math, my guess is you probably chose the one in the top middle. After all, that has solid lead-2 iodide sitting at the bottom and our spectator ions of sodium and nitrate in solution above. However, for those of you who are on to me and you know that I have a tendency to be a little sneaky, you may have done some math. Okay. So if you are one who did not do math, pause the video now, go back, calculate your limiting reagent, and then come back and take a look at these diagrams. Okay, so now that you've done the math, you hopefully have figured out that the lead-2 nitrate was the limiting reagent. So that means that sodium iodide was the excess reagent. So not all of the iodide reacted with lead to make lead-2 iodide. So given that you have iodide left over, that will also be in solution, and therefore the most accurate diagram to represent what will be present in the beaker at the end of the reaction is really the one on the top right. Hopefully this video has been a good refresher on precipitation reactions and that you are more comfortable interpreting particle diagrams. This is something that you will need to be able to do throughout the semester and certainly on the AP exam. The College Board loves these types of questions, so we will practice them a lot as the semester goes on. So that's it for now. I'll see you all in the next class. In the meantime, remember,